Okay, John Marsh here. I thought I had my HD webcam working, but I guess not. So we'll stick with the old camera. I'm here to talk about midterm number 3 review sheet, and I've reprinted it with lots of space in between each problem, and I'll go through these problems giving you the idea, if not doing the whole problem. So, problem number 1. Consider the set B of all bijections F that map the set A onto itself, where the size of the set A is 12. What is the value of the absolute value of B? That is the size of the set B, that is the order of the set. Don't bother to calculate the actual value. And what are elements of B usually called? Well, the elements of B are usually called permutations. When we have a bijection from a set onto itself, they're called permutations. And what we'll do is we'll use the counting principle to count the size of the set B. And I'll say that we have 12 elements that we need to rearrange. Basically, we're rearranging these 12 elements. And we have 12 choices for the first element in the rearrangement. We have 11, 10, 9, so forth, on down to the very last one. We have only one choice, and this is of course 12 factorial, and so the size of B is, that is the order of the set B, is 12 factorial. It's quite large. Okay, so there's problem 1. Let's see if I can do another problem here. Here's problem number 2 on this worksheet. It says, considering the following permutations of the set S. S is the set 1, 2, 3, 4. And I've got these permutations here. Permutation P1, P2, P3, and P4. And you can see that there are rearrangements of those numbers. And so you can see that it's 1 to 1 and on to. And really, when I write P1 equals 1, 3, 2, 4, what I really mean here is that F, well, P1 is a function essentially. P1 of 1 is 1. P1 of 2 is 3. P1 of 3 is 2, and P1 of 4 is 4. And so every time you write a permutation like this, sorry about the jiggling camera here, you can think of having a 1, 2, and a 3, and a 4 right above them. And you can see 1 is mapped to 1, 2 maps to 3, 3 maps to 2, and 4 maps to 4. Another way of thinking about this particular permutation is to take these numbers 1, 2, 3, 4. 1 maps to 1, 2 maps to 3, 3 maps back to 2, and 4 maps to 4. So you can think of it as this rearrangement from top to bottom here. Okay. In any case, we're given these 4 permutations and we need to calculate some compositions of them. The first one is P3 composed with P2. Can we see this down here? Yep. P3 composed with P2, and boy, the jiggle is just a bit much, isn't it? What this means is that we apply P2 first and then we apply P3. And if you want, you can draw P2 up above P3. 2, 1, 4, 3. There's P2. And then here's P3. 3, 2, 1, 4. Okay, and go ahead and draw the numbers up above on each one of them, if it helps. And then you ask yourself, okay, where does 1 go? 1 goes to 2, and 2 goes to 2. So 1 goes to 2. Now we need to figure out where 2 goes. 2 goes to 1 from P2. 2 goes to 1, and then 1 went to 3. So it went to 3. 3 goes to 4, and then 4 goes to 4. You see I'm just following it through here. And then 4 goes to 3, and 3 goes to 1. And if you're doing it right, you should always get 4 different numbers here. Okay, so that's one way of doing it, where you write everything out and follow the numbers through. Here's P3 composed with P4. And you can kind of do these in your head once you get going on it. We're applying P4 first, and then we're applying P3. Where does 1 map to? Well, P4 maps 1 to 4. Where does P3 map 4 to? P3 maps 4 to 4. So we get a 4 here. Now, where does P4 map number 2? P4 maps 2 to 3, and P3 maps 3 to 1. 3 is mapped to 2 by P4, and then 2 is mapped to 2 by P3. And finally, 4 is mapped to 1 by P4, and then 1 is mapped to 3 by P3. And so that's another way of doing these things. You can, of course, write P4 above P3 the way I did before. And P4 is a 1, 2, 3, 4 are mapped to 4, 3, 2, 1. And P3 takes 1, 2, 3, and 4 and maps them to 3, 2, 1, 4. And then you can say, okay, where does 1 go? 1 goes to 4, which goes to 4. 2 goes to 3, which goes to 1. 3 goes to 2, which goes to 2. And 4 goes to 1, which goes to 3. Okay, you can do it in your head once you get the hang of it. Here's P4 composed with P3. This puts the two in different order. We operate on P3 first. With P3, 1 goes to 3, and then P4, 3 goes to 2. 2 goes to 2, and 2 goes to 3. P3 takes 3 to 1, and P4 takes 1 to 4. Finally, P3 takes 4 into 4, and P4 takes 4 into 1. And so you can see here that composition of permutations is not commutative. P3 composed with P4 is not equal to P4 composed with P3. Let's see. Oh, I forgot to. This is actually parts B, C, and D. Part A asks for fixed points, if any. We're looking for a 1 in the 1 spot, a 2 in the 2 spot, a 3 in the 3 spot, or a 4 in the 4 spot. So P1 has a fixed point of 1. P2 has no fixed points. There's not a 1 in the 1's place, there's not a 2 in the 2's place, there's not a 3 in the 3's place, and there's not a 4 in the 4's place. Here I just count 1, 2, 3, 4. And then the 2 and the 4 were in their spots. And here 1, 2, 3, 4, and no fixed points for number 4. Okay. Finally, let's calculate P1 squared. So P1 maps 1 to 1, and if I apply it again, 1 stays 1. P1 maps 2 to 3, and then 3 to 2. P1 maps 3 to 2, and then 2 to 3. Finally, P1 maps 4 to 4, which stays 4. And you can see the P1 squared is 1, 2, 3, 4, which can be considered the identity. And why is that? Well, up here I drew a picture of P1, and all P1 does is interchange elements 2 and 3. So if I apply P1 twice, it leaves 1 and 4 fixed, switches 2 and 3, and if I apply it again, 1 and 4 stay fixed, and 2 and 3 switch back, and it comes back to 1, 2, 3, 4 again. And so now we can see that P1 cubed is going to be equal to P1, because P1 times P1 squared was equal to the identity. In other words, no rearrangement. So P1 cubed is equal to P1. P1 to the 4th is equal to the identity, 1, 2, 3, 4. Okay, and that takes us up through G. Now to calculate inverses. Let's see. P1 inverse. Well, I'm gonna write out P1 like this, and I'm gonna write the 1, 2, 3, 4 above it, and P1 is 1, 3, 2, 4. And what I'm going to do is I'm just going to say, flip this thing over. Here, to apply P1, I say, where does a 1 go? It goes to a 1. Where does a 2 go? It goes to a 3. Well, if I reverse that, I just go from the bottom to the top. 1 goes to 1, 2 goes to 3, 3 goes to 2, 4 goes to 4. Okay? H, P2 inverse. P2 is 2, 1, 4, 3. So 1 went to 2. So 2 goes, well, let's see. 2 went to 1. Oops. In P2, let's write out P2 here. 2, 1, 4, 3. And so we can say that 2 went to 1, so 1 must go to 2. 1 went to 2, so 2 must go to 1. 4 went to 3, so 3 must go to 4. And 3 went to 4, so 4 must go to 3. It always helps to draw the numbers on the top like this. So 1 goes to 2, 2 goes to 1, 3 goes to 4, and 4 goes to 3. And there's my inverse. And I'll leave the inverses of 2, 3, and 4 for you to calculate and end this video here.